Hey guys, today I want to go over the Earth, Sun, and Moon notes that we're doing on day 6 of Unit 2. I have the PowerPoint pulled up here and the guided notes, so follow along with me on both of these if you would. Make sure that we can do this. All right, moving on. All right, so this slide isn't on the guided notes here. It's not right here. What it is to tell you that orbit plays, or gravity plays a role on orbit. Imagine that I'm spinning somebody's keys that are on a lanyard. The reason that it's moving around in a circle is because my hand is holding it in place while I'm moving it. Think of my hand in this situation as gravity's effect on orbit, because if I were to let go of the keys, they would fly off in some random direction. Same thing would happen with the planets in this situation. So let's go through this. What is a mean solar day? This is what we consider in society to be a day, and it's about 24 hours. Okay, so a mean solar day is a time interval from one noon to the next, about 24 hours. However, a sidereal day is the time it takes for Earth to make one complete rotation. That means go from one point in relation to a single point and move all the way around that to the other. That takes about 23 hours, 56 minutes, and 4 seconds. And as you can tell, this is not quite 24 hours, which we consider to be a day. So this shows us that the calendar that we use is imperfect. And there's also more evidence of this in a form that you may have heard of. This is the reason that we have a leap year every 4 years and add a day onto February, is because if we didn't do this, it wouldn't be perfect. Okay, and the sidereal day goes here. Okay, moving on. Barycenter is one of the more important concepts that we'll talk about here. Okay, the barycenter is the point between two objects where they balance each other out. Okay, so if I were to balance, say, this pin, where this pin balances on my finger would be the barycenter. And not all objects are going to be in the barycenter. The barycenter is not always in the middle of two objects. Obviously, if you have a much more massive object on one side and a smaller object on the other, the barycenter, or the center of mass, is going to be much closer to the massive object because it's a lot heavier. It's much more massive. And so that's what we consider to be when we're talking about celestial bodies here. So, for example, when two objects are in orbit, they orbit around this barycenter point instead of each other. Okay. Remember, everything in space is in motion. Okay. I don't know. It's not giving me everything on here, but that's okay. So the solar system speeds into the direction of the star Vega. Let me move down here for you. So the barycenter here, for example, is the center of mass. And we're going to move back here. So everything is in motion. The solar system speeds to the star Vega, and Earth is presently approaching the galaxy of Andromeda. Okay, make sure that you write down here that the sun is not stationary in our solar system. It actually moves as the planet tugs on it. The sun never strays too far from the solar system. Okay, I think we're coming up here. Yep, so the sun is not stationary in our solar system. All right. So the plane of an ecliptic is an imaginary plane that connects Earth's orbit with a celestial sphere. Okay, an elliptic is just an oval. The elliptic is short for the word ellipses, which is just the oval shape that you'll learn in math class. Okay, so because of this, well, not because of this, but also Earth is tilted at an angle of 23.45, 23.5, somewhere around there, degrees. And this is what allows us to have 4 seasons due to the different amounts of light that each part receives and is pointed towards the sun at different times of the year. Okay, so 23 and 4 seasons here. Okay, 23 and 4 seasons. Okay, so moving on from here, we're going to get into precession and nutation. So because Earth is tilted on that axis, it doesn't move just like something that would spin like this. It moves in this kind of direction. Okay, just like a quarter, once you spin a quarter, it starts to slow down, and that hole opens up at the top. The same thing is here, and we call that precession. Okay, so precession is the slow top-like wobbling of the spinning Earth. It has a period of about 26,000 years every time it circles back around. Okay, and precession is caused by the gravitational pull of the sun and the moon on Earth, which is different from nutation. This should be nutation. Okay. Let's see. Let me move over here. So nutation is a small irregularity or wobbling in the precession of the equinoxes. This should be nutation. I apologize. I don't know why this is blacked out here, but it is a small irregularity or wobbling in the precession of the equinoxes. Okay, and this is a change of about 1/2 degree in the angle one way or the other. Okay, this occurs over an 18-year period and is due to the moon's gravitational pull specifically, not the sun in this situation, just the moon. And this would very slightly increase or decrease the amount of seasonal effects there are. I just told you previously that the seasons were due to the tilt of the Earth, so if you change the tilt, it's obviously going to have an impact on seasonal change as well. And here you can, this should be because of the Earth's inclination, or the inclination of Earth's axis to the plane of the ecliptic. Earth has a yearly cycle of seasons. Okay, and so you can follow along with the diagrams here. There's a video that explains that. If you click on this link, I'll put this on the website as well. Okay, so you can fill all of these in here, and you can just highlight as these go along. Okay, let's move on here. Get a little bit about the moon. Okay, the perigee is the point at which the moon is closest to Earth, and the apogee is the moon, the point where the moon is furthest. I talked about earlier how Earth is in an elliptical, or the orbits are in an elliptical shape, and things don't orbit the exact center of an object. So this means that the moon is going to have a point where it's closer to Earth and a point where it is further away. So the perigee is the point where it's closest, which is right here. You can see this from the notes, also from right here. And the apogee is the point where the moon is furthest. Okay, moving on. You can write all these things down as well. I don't need to read all of this for you. You all are capable of reading. We're getting to phases here. So for some reason it continues to black out my things here, but I can let you know what is supposed to be there. So lunar phases are a result of the motion of the moon in the sunlight that is reflected from the surface. Okay? Sunlight that is reflected from the surface. And you can click here to see all about that. Okay, so a solar eclipse, solar is what should be there, is when the moon moves in a direct line between the sun and the Earth, and it casts a shadow on the Earth. And a lunar eclipse is the opposite. Okay, so a lunar eclipse would be right here. You can see the illustration here. Would occur when the moon passes through Earth's shadow. Okay, and that is it for today. I will try to get this thing fixed so the next video can show you everything that you need to have, the same as the PowerPoint that you saw in class. All right, thank you very much.